Mr. Ainsberg here, and we're looking at prime and composite numbers. So the first thing we want to do is define these. And to do that, we're going to use some basic vocabulary first, some basic definitions to kind of help us. Then we'll actually look at some of the more difficult mathematical words. And so the first thing is prime numbers. Prime numbers can be considered numbers that are only divisible by the number 1 and itself. So they're only divisible by two numbers, the number 1 and itself. It has to be both of those. And that's we're going to kind of get into an exception on why certain numbers aren't considered prime. Well, composite numbers are the other numbers. And so that means they have numbers that are divisible by not just 1 in itself. So composite numbers are not prime. It's the others. So what are the exceptions? Well, if you look at the definition, it says numbers that are divisible by 1 and itself. And so two of the exceptions that we have are the numbers 0 and 1. Those are neither prime nor composite, because 0 itself, weird number, we'll get into that a little bit later. 1 deals with, well, it has to be divisible by 1, which it is, and itself. Well, itself is the number 1. So we already took care of that rule. So it's not divisible by two numbers, the number 1 and itself, because 1 is itself. So only satisfies one of those rules. So in other words, just think of 0 and 1 as exceptions to the rule. They're neither prime nor composite. Now, the mathematical definitions, instead of saying numbers only divisible by, is, prime numbers have factors of only 1 and itself. Composite numbers have other factors besides 1 and itself. And so you have the term factors. And so that's a term, a mathematical term that is used constantly the further you go in mathematics. So we have to understand what that means. And so factors are numbers that are multiplied together. So if you're doing multiplication, if you have two numbers multiplied together, those two numbers are considered to be factors. So you can look at an example of that. I mean, if I have basic 3 times 4 equals 12, it's a basic multiplication problem there. Well, what that means is that I have a product of 12. Equals after multiplication is your product. The end result of multiplication is product. Well, my product is 12. So 3 and 4, those are the two numbers that multiply together. So we consider those to be factors of the number 12, because you can use those with multiplication to create the number 12. Well, another example, if I have 2 times 6 times 11, that is 132. Well, wait a minute, that's 3 numbers, and that's okay. It's any time that you have numbers being multiplied together, those are all considered to be factors. So my product is 132. The end result of multiplication, called a product. The things that create it, the numbers that create it through multiplication, those are factors. So 2 is a factor of 132. 6 is a factor of 132. 11 is a factor of 132. So numbers that are used to create through multiplication a product are factors. So let's look at one more thing. Now, how is this used when we're dealing with factors and dealing with prime and composite numbers? Well, to be a factor of a number means that it has a remainder of 0 when you're dividing into that number. So if I'm dividing into that number, so if I want to take 150 and I want to divide by 10, the end result of that would be 15 with no remainder, which means that 10 is a factor of 150. So to be a factor means that when you divide, it has a remainder of 0. Now, another way that I like to think of it as is, because we're really good with multiplication tables, is it can be used to create the number using multiplication. So if I want to create the number, let's just say 270. Big number, I know, but here's the good news. It ends in a 0. So I know I can use 10. So that means if I can use 10 to create through multiplication 270, let's see, so if I have 270, I know I can create 10. So 10 times 27 is 270. So that means 10 is a factor of 270. 27 is a factor of 270, which, by the way, let's kind of have a little fun here. This kind of leads into factor trees. Is if I go a little bit deeper with this, can't 10 be written as a product of 2 and 5? I mean, 2 can be used to create 10. 5 can be used to create 10 through multiplication. So that means 2 is a factor of 10. 5 is a factor of 10. Which, by the way, doesn't that mean 2 and 5 can be used to create 270? Because 10 was used But 2 can create 10. So if 2 can create 10 and 10 can create 270, then that means 2 can be used to create it. I mean, you can kind of even just look at it the way it's shown right here. I mean, this right here is the number 10. So I didn't change anything, I just rewrote it. Let's go a little bit further because it's fun. I did that to the 10. Can I do that to the, let's say, 27? Isn't 27 9 times 3? So rather than doing this, can I go, hey, you know what? I'm going to replace that 27 with a 9 times a 3. So is 9 a factor of 270? Yes, because 9 can be used to create it through multiplication. And I could keep going with these factor trees. I could break 9 down more if I wanted to. But the idea is, what is a factor? And we're going to look at how is this used when we are dealing with our prime and composite numbers and dealing with factor trees and stuff like that. So this is the main idea that you're dealing with when it comes to what are prime numbers, what are composite numbers, and what are the factors. Now to find them, that's the next video. Mr. Razor back to continue the discussion of prime and composite numbers, and this time we're looking at how to deal with them when it comes to finding prime and composite. And this is just the beginning stages. This is kind of the foundation on how do we determine if a number is prime or composite. And so you can see, remember, prime numbers are only divisible by 1 and itself, and composites are divisible by not just 1 and not just itself, but other numbers. And we have the definition of factors from before as well, which are numbers that are multiplied together. And remember, we looked at 3 times 4 equals 12. 3 is a factor of 12. 4 is a factor of 12 because they can be used to create the number 12 through multiplication. And that's really what a factor can be looked at as. So if you look up above, you can see I have a lot of numbers listed out. 0, 1, 2, 3, 4, ... all the way 15, 16, 17, jump into the 200s, and then, yes, it even goes into the 3000s and further. So we're going to try and look at what to do with these and how we can determine if they are going to be considered prime or composite. And the first thing that we need to keep in mind is the exception to the rule for prime and composite numbers, which is in red up above, and that is 0 and 1. 0 and 1 are neither prime nor are they composite. They are the exceptions to the rule. And so we cannot use those. So we're just going to focus on the numbers 2, 3, 4, all the way up forever. And we need to figure out which are they. Are they prime or are they composite? Now, it's probably not hard to figure it out when it comes to the beginning numbers. The beginning numbers are probably not too bad. If I do 2, 3, 4, 5, 6, 7, 8, 9, all the way to 17, and maybe a little bit more, those aren't hard to determine if they are prime or composite, because those are just really our basic multiplication facts. So if you have your multiplication tables memorized, let's just say like 1 through 12 memorized, knowing that will help you with some of your prime versus composite. So, you know, the beginning numbers aren't too bad. But then I jump into some bigger numbers. I jump into the 200s. And in that case, maybe those are going to be just a little bit more difficult. The difficult level might be medium. Maybe I don't know if 203 is prime. I can't quite figure that one out. It's just as fast as the others. Maybe I don't know if 217, 18, 19, maybe I don't know if those are prime, which, by the way, 219 is not prime. It's composite. So there's a way to know by looking at them, and that's where we're going to be expanding in this video. And then, so it gets more difficult, medium difficulty, then you got the really, 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 really big numbers. And in that case, man, those are hard. How do I know if 3,155 is going to be prime or not? How do I know if 3,156 is going to be prime or composite? Those are the ones that you're going to have to go, wait a minute, that's a little hard. Which, by the way, 3,155, composite. 3,156, composite. So that means if I could say it that fast, there has to be a trick I can use. And so in mathematics, when things get difficult, you have to realize that's the beauty of math. Because if things are difficult, you go to the things that are easy. Because things that are easy are used to create the foundation for the things that are difficult. So you know what I'm going to focus on? I'm going to focus on those. 2, 3, 4, 5, 6, 7, 8, 9. Those are easy numbers to tell if they are prime or composite, aren't they? So you know what I'm going to do? Let's use these. And so in this video, what we're going to do is we're going to look at all the divisibility rules for 2, 3, 4, 5, 6, 7, 8, 9. Because if I can check if a number is divisible by those, it'll be quick and easy for me to determine if a number is prime or composite. So now let's look at the divisibility by rules to help us determine if a number is either prime or composite. And the first one we're going to look at is checking for divisibility by 2. And now that's easy. Because if it's divisible by 2, then it's going to be considered an even number. And so this one, I'd say this is the easiest. This is the first thing you should check. You always just want to check, hey, is it even? Because if it's even, I know I can divide by 2. And so if we take a look, we have 2, 4, 6, 8. You have all the even numbers. This is an easy list to look at to see if a number is divisible by 2. And you just go through and look at the last digit, and is the last digit even? And also do look at the middle part where we have 1,178. Then you have 1,180. If it ends in a 0, it's even as well. It still counts. Now, because this is the easiest, it may be one you kind of go, oh, I know this, and then you don't think about it. But I want you to put this on the back burner, because we are going to actually come back to the divisibility by 2 rule a little bit later when checking the others. So let's move on to the next one. So the next one we're looking at is checking for divisibility by the number 3. This one is really cool. This one I use constantly, and it's amazing to kind of look at. And the rule is this. The sum of the digits is divisible by 3. If I add all the digits in the number, and that sum is divisible by 3, the entire number is divisible by 3. And so I like this one. It is a great trick to know. So we knew even, divisible by 2. This one's divisible by 3, and it is something to always keep in mind. It's a quick way of just doing basic addition and determine if a number is divisible by 3. And so you can see here some of the basics, 3, 6, 9, 12, 15, 18. Well, those are my multiples. That's not bad. Let's go to kind of the medium ones. 72. Well, wait a minute. I'd have to kind of think for a moment. Well, 7 plus 2 is 9. 9 is divisible by 3, so that does mean 72 is divisible by 3. 3 goes in there 24 times. 75. Well, 7 plus 5 is 12. So that means 75 is divisible by 3, which, by the way, 3 quarters is 75 cents. So 3 times 25 is 75. And you can continue. And so that's kind of the beginning of, well, it's not too hard. I got to think about it for a moment. I could do the long division if I wanted to. But then we go into these 3 digits. Do you really want to do the long division here? Or could I do 1 plus 9 plus 2? 10 plus 2 is 12. 192 is divisible by 3. 195. 1 plus 9 is still 10. 10 plus 5 is going to be 15. So that means 195 is divisible by 3. Now, that last one I put there for a reason, that 201, because you may go, wait a minute, that looks weird, might be prime. But 2 plus 0 plus 1 is 3. 3 is divisible by 3, so therefore, so is the number. And I can keep going. So even these, I have 3-digit numbers, 744. Now they get bigger, but 7 plus 4 is 15. It's divisible by 3. Even getting bigger, that's huge, 9,252. How am I supposed to know if that's prime or composite? Well, it's even. That's good news. So I know it's divisible by 2. Also, 9 plus 2 plus 5 plus 2, 7 plus 11 is 18. 18 is divisible by 3. Well, 9,255. How am I supposed to know if that's prime or composite? Well, it ends in a 5. We'll get to that. That means it's divisible by 5. But also, 9 plus 2 is 11. 5 plus 5 is 10. 11 and 10 combined to give you 21. It's divisible by 3. So it's a great trick to hold on to. Because the larger the numbers get, 5 digits, 6 digits, if you just do basic addition and look at that sum, if it's divisible by 3, so is the number. And again, just like I had you do with this divisible by 2 up above, I said put it on the back burner. The same thing with divisible by 3. We're actually going to come back to this one again. So now we're moving on. And you may think, well, I did 2, I did 3, I'm going to go on to 4. And I'm not going to. We're going to hold off on 4 for now. We're also going to hold off on 5, we're going to hold off on 7, and we're going to hold off on 8. We're not going to do those. So if you can tell, that means I'm going to be jumping into divisibility by 6. And the reason why I'm going to do divisibility by 6 next is because that one goes with divisibility by 2 and divisibility by 3. If I check both of those conditions, then that means the number itself is going to be divisible by 6. And the reason why? What numbers multiply to give me 6? what numbers are factors of 6? I use the same vocab we used before. Well, the factors of 6, the numbers that can be used to create 6 by multiplication, are 2 and 3. So if I look at those rules, the rule for divisibility by 2 is the number's even. The rule for divisibility by 3 is that the sum of the digits is divisible by 3. Well, if I look at that, and it has to match both of those. And then you can see up above that you have the word and underlined. It has to be both. And so you can see here, I don't have my list of numbers there. Now I do. So I have two different colors. And because if you look at it, and I'll go in this order, we can see the basic ones. We know our multiplication table for 6, so it's not too bad in the beginning. But I want to show the easy, because the hard, it expands from the easy. The easy is the foundation. We can't rush through it. 6, 12, 18, 24, the gray, those work. Those are divisible by 6. 9, that's divisible by 3, but it's not even. So therefore, that one doesn't work. 15, that is divisible by 3, but it's not even. 21, it's divisible by 3, but it's not even. Notice 24, 2 plus 4 is 6, which is divisible by 3, and it's even. So therefore, 24 is divisible by 2, and it's divisible by 3, so therefore it's divisible by 6. We can go into bigger numbers. So now it might get a little more difficult. But if I look at 156, it's even, so that covers divisible by 2. Now, 1 plus 5 plus 6 is 12. So therefore the sum is. But 1 plus 5 plus 3, that's odd. Even though 1 plus 5 plus 3 is going to be 9, it's divisible by 3, 153 is odd. So it's not divisible by 2. And the same thing here, 744 and 747. If I take 7 plus 4 plus 4, and let's just say I do 7 plus 4 plus 7, those have sums that are divisible by 3. But only one of those numbers is even. So therefore, 744 is going to be divisible by 3 and 2, so it's divisible by 6. And the same thing goes when the numbers get bigger and bigger and bigger. First thing, maybe I want to check for, if you can tell, between the two, between determining if it's divisible by 2 or divisible by 3, which one's fastest? Even. So I might as well quickly check, well, that's not even, that's not even. So I can take a look at it and go, well, 1 plus 4 plus 3 plus 4, so 5 plus 7 is 12. That works, that's divisible by 3. 8 plus 7 is 15, 6 plus 6 is 12, that's 27, so that's divisible by 3. So I would check for, when I'm doing divisibility by 6, I would do it in the order from easiest to hardest. Check out the evens first. Why? That eliminates all the odd answers automatically, correct? So it goes down pretty fast. And then check if it's divisible by 3. So when you're doing divisibility by 6, check for divisibility by 2 first, then check for divisibility by 3, and that will tell you is the whole number divisible by 6. So now let's move on to the ones that we skipped. Let's go back to where we were. We are now checking divisibility by 4. Now this one is another one that's really good to be able to do in the back burner because it's very helpful, very, very helpful with large numbers. The larger the number, the better it is to check this one if it's divisible by 4. And the rule is the last two digits, the ones digit and the 100s digit, that 2-digit number has to be divisible by 4. That's it. And the reason why this works is if you have the number 100, and I'm going to think of 100 as $1. I know 4 quarters, 4 times 25, is 100. 4 quarters is $1. So I know 100 is divisible by 4, which means 200 is divisible by 4, which means 300 is divisible by 4. And if I go up to 1,000, well, 1,000 is really going to be 10 100ths. So I have 10 numbers that are divisible by 4. So that means 1,000 is going to be divisible by 4. And I can keep going to 10,000, 100,000. So as soon as I hit that 100s digit, anything bigger, 100s digits, 1000s digit, 10,000s digit, any digits bigger than that are going to automatically be divisible by 4. So I only have to check the last 2 digits. It's a very, very good trick with really, really large numbers. And so you can see here again, we start off with easy. We know our multiplication tables. And so maybe we can go right down to 4, 8, 12. We get it 52, 56, 60. We got to think about it a little bit more and so on and so on. But then we start getting into bigger numbers. 136, 140, 144. And I go, wait a minute. Can't do that fast mentally, at least to see if it's divisible by 4. However, I can look at the number 36. 36 is divisible by 4, which means 136 is divisible by 4. In fact, it's going to go in there, let's see, 34 times. 140. Well, 40 is divisible by 4. We already know the 100th digit is divisible by 4, so all we care about are the last two digits. And the same with 144. We can check that, and you're going to have that it's going to be 36. It goes in there, because I can look at the last two numbers and figure it out. So I can even go bigger. So, bigger numbers, 712, 716, 720. Maybe I don't know what that is. But if it's divisible by 2, 3, 4, 5, 6, well, that's a big number. Let's just look at these last two digits first. I know the 100th digit is going to be anything bigger than that. It's going to be divisible by 4. So let's just look at the 10s and the 1s. 12. That is. 16 is. 20 is. Which means that 712, 716, 720 is divisible by 4. Wow, we get really big here. 9,328. How am I supposed to know what that breaks into? Well, good news. 28 is divisible by 4. So that means 9,328 is divisible by 4. Because we know the 100th digit is going to be divisible by 4. We know the 1,000th digit is. I don't care about those. I only care about the last two digits. Let's have a little bit of fun, though. That's a big number. That one's huge. I mean, look at this. There's the break. There's the break. There's the break. I have 53,176,100,908. How am I supposed to know 4 goes into that? Well, because I don't care about the 100s, the 1,000s, the 10,000s, the 100,000s. You hear. I don't care about these bigger ones. I only care about the last two digits to determine if it's divisible by 4. And in fact, 08, the number 8, is divisible by 4, so is that entire large number. So this is a really good one to check when you're dealing with big numbers. All right, so let's move on to divisibility by 5. You probably don't even really need me to tell you about the divisibility by 5 rules, but I'm going to do it anyway because it's fun. You want to check if the number ends in a 0 or a 5, if the 1's digit is a 0 or a 5. This one, easy to use. So even numbers and divisibility by 5, those are the quickest ones in my mind to check. So you can see my list, 5, 10, 15, 20, 25, 30, 115, 120, 125. They end in a 0, they end in a 5. And you can see even the bigger numbers I get to. It doesn't matter what they are as long as they end in a 0 or they end in a 5. That's the divisibility by 5 rule. Now, let's move on because that's fast. Let's check divisibility by 7. Remember, because we already did 6. 6 fits the criteria of has to be both even and divisible by 3. Both those two rules. So when we're looking at this one, gotta tell you, here's this rule. The difference of twice the 1's digit and the remaining digits has to be divisible by 7. That's really it. I mean, makes sense, right? Now here's my opinion about this. Yuck. I don't even really remember this one because it's got multiple steps on it. It's a little bit harder than the others. If I'm going to check for divisibility by 7, I'm probably going to work through all the other numbers first. This one is really hard to remember. And so it's not one that you're going to really kind of reach in your back pocket and grab. It's one you're probably going to avoid. And it's completely understandable. Because you're going to have to remember that rule. Okay, I got to do twice the 1's digit and then subtract that value from the remaining digits. And by the way, what does that mean? So you can see I wrote down all the multiples of 7. And the thing that's hard about it is if I take a look, if I do twice the 1's digit on 5,215, that's going to be 10. And then I got to take 521, subtract 10, and I get 511. I got to figure, okay, is 511 divisible by 7? So now it's getting, I still have a large number. Does that make sense? I still have a large number. So, I don't know about that. What about this? 9,653. So twice the 1's digit is 6. Okay, that's not bad. Well, now I have to take 965, subtract 6, get 959. Is 959 divisible by 7? You see how the larger the number gets, this divisibility by 7 rule just kind of becomes really difficult. There's no point to doing it. You might as well check for other numbers. I mean, I might as well check, hey, 5,215 ends in a 5. Might as well check that one. 5,222, it's even. Might as well check that one. And then I can keep going that way. By the way, 5 plus 2 is 7, plus 2 is 9, 9 plus 9 is 18. 5,229 is divisible by 3. So I might as well check the other ones, because no one's going to remember this divisible by 7 rule. Now the other ones, 8 and 9, aren't too bad. So divisibility by 8. Now this one, let's think about this. Do I know any factors of 8? So see, I'm using that vocab word for you is factors. They're numbers that when multiplied can create 8. So do we know any factors for 8? And I do. 2 and 4. 2 and 4, if I multiply those together, can create the number 8. So that means 2 and 4 are factors of 8. I'm actually kind of using the same idea I did with the number 6. Is if the number is even, it's divisible by 2. So now I got to check, is it also divisible by 4? Are the last 2 digits divisible by 4? So if I want to check divisibility by 8, I might as well see, is it an even number? And are the last 2 digits divisible by 4? That will tell me if it is divisible by 8. So again, we start off with the easy ones. We know 8, 6, 24 multiplication tables. 88, again, easy. 96, not bad. How about 104? Well, it's even. And if I look at the last 2 digits are the number 4. And so therefore, it is divisible by 8. 112. And maybe it's a little difficult for you to know, just quick off the head instead of doing long division, but I do know it's even. And 12 is divisible by 4. So you can see when we get here to some of the larger numbers like 424, it's even, and the last 2 digits, 24, is divisible by 4, so therefore the whole thing's divisible by 8. And it's helpful when you get to larger numbers again. 9,356, it's even, so therefore it's going to be divisible by 2. And the number 56, the last 2 digits, are divisible by 4, so therefore 9,356 has 8 as a factor. You see how I threw that curveball there? Instead of saying it's divisible by, I'm using the term factor. So what about, I have here 7,309,272. How do I know if that's divisible by 8? Well, it's even. That takes care of that criteria. Now let's look at the last 2 digits, 72. So 72 is divisible by 4. So let's use the vocab. That means 2 is a factor of 7,309,272. 4 is a factor of 7,309,272. So therefore, 8 is a factor of 7,309,272. Or 8 goes into 7,309,272. Or 7,309,272 is divisible by 8. It was just fun to go through that rant. So, that one's divisibility by 8. Now, divisibility by 9, it's actually very similar to the divisibility by 3. The sum of the digits have to add up to 9. Have to add up to a multiple of 9. In other words, the sum of the digits is divisible by 9. So, great trick to know, just like the divisibility by 3 is. So, 9, 8, 27, 36, and so on, not bad. Even 90, 99, not bad. But what about 117? 1 plus 1 plus 7 is 9. The sum is divisible by 9, so is the entire number. Even the bigger it gets, 567. 5 plus 6 is 11, plus 7 is 18. Therefore, 567 is divisible by 9 because their sum is 18. Or 9 is a factor of 567. What if we get bigger? 855. Wow. How am I supposed to know? Well, 8 plus 5 plus 5 is going to be 18. 18 is divisible by 9, which means that 9 is a factor of 855. And then you go bigger and bigger and bigger. 4,032. Well, 4 plus 0 plus 3 plus 2 is going to be the number 9. 9 is divisible by 9, in case you're wondering. So therefore, 9 is a factor of 4,032. 4,032 is divisible by 9. Now, these are a lot of rules, and I understand that. We're looking at divisibility by 2, 3, 4, and you may go, how does this relate? How does this relate to prime and composite numbers? Well, if I want to check if a number is prime or composite, I have to see, do other numbers go into it besides itself and 1? Does 2 go into it? Does 4 go into it? Does 3 go into it? And if I can check those, then I can determine, hey, if there's another factor besides 0 and 1, then it's going to be composite. If there's not, then it's prime. So knowing these rules will help you along the line when it comes to determining is a number, in fact, prime or composite. Because I need to check, does it have any other factors besides 1 in itself? And which ones do I use? I use the easy ones. Why do I use the easy ones? Because in mathematics, the foundation is the easy stuff. You get that stuff memorized, and all the medium stuff, all the hard stuff builds from that. So I hope this helped. Thanks for watching.